Alright guys, so welcome to chapter 6. Alright, looking at some reliability and validity. So very important as we're talking about when you're creating some research and some testing. Okay, and what we want to make sure is you understand the difference between. Okay, so concepts of reliability, it relates to the consistency or repeatability of an observation, to which repeated measures of the same trait are reproduced under the same conditions. Also described as consistency, dependability, stability, and precision. The greatest thing we could do, and there's a bunch of different types of reliability, as you know, is to be able to take the test that we do, whatever you pick, and replicate that over and over and over again with conditions, okay, which is important under the same conditions. For instance, if we're doing a T-drill test, there's going to be a big difference if we're doing it on a football field with spikes versus a gym in gym shoes. Okay, so we got to make sure the conditions are the same. Okay, concepts of validity. Validity is the degree of truthfulness of a test score, depending on two characteristics: reliability and relevance. You need the test to be reliable in order for it to be even valid. Relevance, on the other hand, is the degree to which a test pertains to its objectives. Okay, so it has to be relevant to what you're testing. Okay, so if you're testing basketball players and the reactive time to whatever, it has to pertain to basketball players, whatever test you're going to do. Okay, so you can't have a statement without having the actual test be relevant to that population. All right, objectivity is a special kind of reliability, also known as inter-rater reliability. Objective tests, multiple choice, differ from subjective tests in essay, in which they are less biased and or influence regardless of the rater. You have to, for inter-rater, which is very important for my research, for my PhD, is I need to have raters perform the test that I want the same as me. We want all raters to perform the test. For instance, we'll go back to the T-drill. If myself and 3 other raters are timing it the same exact way under the same conditions, that one person, say we have the same subject, the one person, and they tested with myself and 2 other people, their times should be pretty darn close, depending on rest time and stuff on a T-drill. That's inter-rater reliability, okay? It's very important. Reliability, again, is Pearson product moment. Correlation coefficient is used to provide evidence of a test reliability. Okay, so that Pearson correlation. Observed error and true scores are theoretical concepts that will help you understand the concept of reliability. Okay. Goes through an example here. Observed scores is sum of the true score and error score combined. True score theoretically exists but is impossible to measure. Okay, the actual true score. Error score results from anything that causes your observed score to differ from your true score. Okay, reliability, this is how reliability is found, but again, we are not going over the math behind it. Just understand that it is gettable via numbers and what is given to you within a problem. Theoretical conclusions of reliability: observed score variance equals true score variance plus error score. Reliability coefficients range from 0 and 1. Desirable level of reliability is 0.8 or greater. Okay, so closest to 1 we want to get. Generally, longer tests are more reliable than shorter tests. So longitudinal studies, okay, looking at things for a longer period of time are usually better than one moment in time. You do not have to worry about interclass coefficients, okay? Interclass reliability, again, we're looking at test-retest reliability, which is going to be the biggest one. We'll go through all 3 of them. All right, test-retest reliability is a single test that is administered twice to participants. Okay, so for instance, I'm doing the FMS. FMS is administered twice to the participants. Scores of that separate test administrations are correlated using the Pearson correlation coefficient. Okay, if the time between testing occasions is longer, the test-retest reliability is often called stability reliability. Is that same thing one day going to be retested the same the following day or a couple days later? Okay. So if you look at the sit-up, this is a classic example of this kind of test. All right. So for instance, participant 1, first trial is 45 sit-ups, second trial is 49. So you can see they're really darn close to each other. Okay. Increasing reliability. The equivalence reliability: 2 parallel or equivalent forms of an exam are given to participants. Scores in each exam are correlated using Pearson to determine the level of agreement between the two exams. Split halves, administering the same test twice, or two separate tests may not always be the best option. Again, the most thing we're going to see is going to be this test-retest. That is going to be probably more often where your test that you're going to devise is going to take place, because you want to have replicability of that test, right? Going back to being reliable. We want to have the reliability in that same test that you're doing. Okay. Moving on. Interclass reliability. The interclass model allows you to estimate reliability for more than 2 trials. It also addresses the constant difference problem that can be seen in interclass models. Okay, so you can see a little bit difference here. A little bit more variance in the scores. Okay. Don't worry about Cronbach's, alpha coefficient. Index reliability you do not have to know. Standard error measurement reflects the degree to which a person's observed score fluctuates as a result of errors, right? It's a standard deviation of errors in measurement around the observed score. Here are some factors that affect reliability: fatigue, right? Practice, participant variability, time between testing, circumstances, appropriate level or difficulty of tests, precision of measurement, environmental conditions. Okay, so these are all play a role in all of our testing. Okay, for instance, looking back, when we do all of our testing on each other, right? Whoever has the first couple tests are going to be more apt to have better results than, say, if we do all of our tests and we sequence, say, a 300-yard shuttle at the end, the scores aren't going to be as good as if we did the 300 shuttle at the beginning. Okay. Validity, we have a couple: content, criterion, and construct. All right. Content is evidence or truthfulness based on logical decision making, also known as face validity and logical validity. Content experts, expert judges, colleagues, and textbook writers can serve as sources of valid instrument of content. Criterion is based on determining the relationship between a criterion and other measurements used to estimate criterion, also known as statistical validity and correlational validity. Concurrent validity, all right, criterion is measured about the same time as alternate measure. Predictive validity, criterion is based on the future. FVO2 would be a great example of a concurrent validity. Okay, distance ran, sum maximal, non-exercise model. So they all relate, just in different ways. Okay. Predictive validity, heart disease is a good example here. Preset diet, exercise behaviors, blood pressure, family history. And then we look at success in graduate school, graduate record examination, undergraduate grade point average. So we're predicting the outcome, possibly, of that student. Okay. Sources of a criterion measure: actual participation, known valid criterion, expert judges, turnaround participation, known valid test. Construct, used to validate measures that are unobservable. Evidence that combines logical content, statistical validity procedures. If in theory the construct is valid, then such and such should occur. Associated with convergent and discriminant evidence. An example of construct-related validity is a student who is poor at golf should test poor at golf. Conversely, somebody who is really good at golf should test good at golf. Diagram of validity and reliability terms. This is a great thing to have because it also goes into certain testing criteria as well. So it's a really good diagram of validity and reliability. Okay, and then let's see what else we need. I have to know about the Bland-Altman test. Okay, so going back, make sure that we're understanding reliability and validity. We need to be more reliable in order to be valid, right? You cannot have a valid testing criteria without it being reliable. So doing that inter-rater reliability, inter-class reliability is going to be important. Test-retest will be very important, probably the most important for you guys. So understanding those objectives is crucially important to your success in administering good testing protocols. So I will see you guys tomorrow. Have a great day.